This is my beginning algebra course. Today we're going to multiply and divide algebraic fractions. If you haven't done the homework completely and correctly from the last class, do that homework before watching this video. We're going to start with pre-algebra review. In pre-algebra we learned how to multiply algebraic fractions. So when you multiply fractions, remember just multiply the numerators and then multiply the denominators. So 5 times 3 is 15. And of course it's going to be a negative. X to the 4th power times x to the 3rd is x to the 7th. Just add the powers. And we can't combine y's in the numerators or z's because there's only one y expression and one z expression. 7 times 10 is 70. And now we just have to simplify it. So I know that 5 goes into both these numbers. Now if I kept the bottom in factored form, instead of writing 70, if I wrote 7 times 10, then that would help me factor. Because I know that if I divide both these, both the numerator and the denominator by 5, then 15 becomes 3 and 10 becomes 2. But if that confuses you, then we can just leave it as 70 and you can use a calculator. Alright, so 15 divided by 5 is 3, and 70 divided by 5 is 14, and x to the 7th, and we subtract the powers and the y's, so we'd have y to the 2nd, and we subtract the powers and the z's, and we get z to the 2nd also. So why did the z's end up in the bottom? Because there's more z's in the bottom than on the top. And why did the y's end up on the top? Because there's more y's in the top than the bottom. So again, that's just a pre-algebra review. So why don't you try number 2, and when you come back we'll do it together. Alright, we're back. So you should have negative 18 over 33, x to the 5th, so on and so forth. And divide 18 by 3 and you get 6, and divide 33 by 3 and you get 11. And so on and so forth. And so if you got that answer, good job. I should probably write the 11 in the center to make it more symmetric. So again, this is pre-algebra review. Alright, let's try number 3. Now number 3, let's do that one together. So I'm just going to rewrite negative 12y to the 2nd, but I'm going to write it as over 1. Because remember, this looks like a whole number term, so you just write it over 1. And then you just multiply like normal. So we don't really have a lot of room to do that. So instead of rewriting it, I'm just going to go ahead and multiply it. But again, just be aware that you can write negative 12y squared as over 1. So negative 12 times 4, or negative 4 is 48, so on and so forth. And now we just have to reduce that. 48 divided by 3 is 16. You can also think of it as dividing both sides by 3. 3 divided by 3 is 1. 48 divided by 3 is 16. And so there we go. So now you try number 4. When you come back, we'll do it together. Alright, we're back. And we just have to reduce. Divide 21 and 14 by 7 and you get 3 over 2. And the y's just cancel out. So if you got that answer, good job. So now we go to division of fractions. We're still in pre-algebra review. So remember, when you divide fractions, you have to change the operation from division to multiplication, and then you flip the divisor. And you can use a dot instead of parentheses, or you can use parentheses for multiplication. It's really up to you. I'm just going to go ahead and use parentheses, because that's what I did in the last class, or the last course. But you are going to see dots later on in this class for multiplication. So again, when you divide fractions, you just change the operation to multiplication and you flip the divisor. The divisor is always on the right. And then it just becomes a multiplication problem. So like the previous problem, you just multiply those two fractions. Now we just have to reduce. Divide both sides by 3. And that's the final answer. All right, so why don't you try number 6, and when you come back, we'll do it together. All right, we're back. Change to multiplication and flip the divisor. That just becomes a multiplication problem. And then we have, actually there's nothing we can do at that point. So we're pretty much done. So for number 7, number 8, we have the same situation, except we have a whole number term, what looks like a whole number term. Whoops. So again, before you do anything, consider this whole number to be over 1, this whole number to be over 1. So let's do the first one together. And again, consider this to be over 1. And now we just have to reduce. So 66 divided by 6 is just 11. X cubed, y to the 4th, z squared. So why don't you try number 8, and when you're done, we'll do it together. All right, we're back. So we flip the divisor. Again, this is considered to be over 1. But don't mess up the original problem. You don't want to put over 1 on the original problem. So we flipped it, changed to multiplication, and Now we just multiply straight across. So now we just have to reduce. And there's only one thing we can do to reduce. On the x powers, it's 5 minus 3 is x squared. So we're left with y to the 7th on the top and x squared on the bottom. So if you got that answer, good job. Alright, so again, that's pre-algebra review. Now we're going to go into the actual beginning algebra material for this course. That was just to refresh your memory on the pre-algebra material. So we learned how to factor 6 different expressions: quadratic expressions, the difference of two squares, expressions with more than one variable. We learned how to factor by grouping, and other types of factoring that I don't remember. Oh yeah, greatest common factor, so on and so forth. So we're going to use those types of factoring when multiplying and dividing algebraic fractions. So here's what we're going to do. We're not going to multiply straight across, because remember, when you multiply fractions, usually what you do is multiply the numerator straight across, and then you multiply the denominator straight across. We're not going to do that. We could do that, but that would be really, really, really difficult, and it would give us an expression that is really not reduced. So what we're going to do is we're going to first factor everything that we can factor. So you can see that this is a quadratic expression, so we can factor that. This is an expression with common factors, so we can factor out a GCF, a greatest common monomial. And this is an expression that we can factor because of the difference of two squares. And we cannot factor x plus 4 because there's really nothing to do there. So we're going to factor everything. So first we'll factor x squared plus 9x plus 14. So that will be x and x, and what two numbers multiply to 14 and add up to 9? That would be 7 and 2. All right, then we're going to factor this green part here. So we're going to factor out the greatest common factor. That would be 3x. And you're left with x plus 4 inside. And then we're going to factor this yellow part here, the difference of two squares. And remember, if you have the difference of two squares, that would just be two pairs of parentheses, and then what number times itself equals 4, that's 2, and then you have your plus and your minus. And by the way, I didn't mention, notice that we have the dot here for multiplication. Sometimes you're going to see a dot for multiplication. Now we could put parentheses, but in this case, whoever wrote the problem set just decided to use dots. And of course, we're just going to rewrite the x plus 4 because we can't factor that. All right. So at this point, I realize I can't use my colors. I gotta get back to white there. Because I have to use my colors to cancel out, or my highlighters. So we're going to cancel out all the things that we can cancel out. So remember, if there's a common factor on the top and the bottom, then we can factor it out. But in this case, we can actually factor out things that are on totally different fractions. For example, there's an x plus 2 in the bottom on this fraction, and there's an x plus 2 in the numerator and the other fraction, so we can cancel those out. And it turns out that if there's a common factor on the same fraction, of course, we can cancel that out. We learned that in the last class. But so we also see an x plus 4 here and an x plus 4 here. So again, it has to be on the top and the bottom. It doesn't matter if it's on the same fraction or a different fraction. And it looks like at that point we're done. So then we just multiply straight across. Now notice that because this x plus 4 canceled out, there's actually nothing in the numerator. If there's nothing in the numerator, it's assumed to be 1. So now we're going to multiply straight across, because that's what we do when we multiply fractions. We multiply straight across in the numerator and the denominator. But in this particular problem, we canceled out first, and then we're going to multiply straight across. So we can just consider that to be x plus 7 times 1, which is x plus 7. And at the bottom we have 3x times x minus 2. So the parts that are not highlighted are the parts that are left over, and then we just multiply straight across. But again, because the green x plus 4 here canceled out, this expression is assumed to be 1. So it's 1 times x plus 7 is x plus 7. And 3x times x minus 2 is, of course, just 3x times x minus 2. Now you can distribute this denominator if you want, but I'm not going to make you do that. It's not really necessary. So that's the principle that we're going to be using in this class. We're just going to factor everything that we can, and then cancel out, and then write the final answer. That's it. That's the whole class. All right, so let's try another one together, and then you can try the next one on your own. So we cannot factor y to the 4th, so we're just going to keep that. But we can factor the denominator. That's a quadratic expression. And it looks like it's going to be plus 5 and negative 1. And then we can factor the quadratic in the numerator on the other fraction. And it looks like it's going to be plus 5 and negative 3. Again, what two numbers multiply to negative 15 and add up to 2? And we cannot factor y squared. So we just leave that as y squared. So now, if something's on the top and the bottom, a factor that's on the top and the bottom, we can cancel. So y plus 5 and y plus 5, we can cancel that out. But we can also cancel some of these y's here, because they're factors. So y to the 4th over y to the 2nd. So you just subtract the powers. 4 minus 2 is 2. So we're left with y to the 2nd up here. And then we multiply it by y minus 3. And in the bottom, there's nothing here anymore, so it's just considered to be 1. So y minus 1 times 1 is y minus 1. So same type of thing. All right, so it's time for you to try. Go ahead and try number 11. You're just going to factor all those quadratic expressions and then cancel out what's on the top and the bottom and write your final answer when you multiply across. So try number 11, and when you're done, we'll do it together. All right, we're back. So again, these are all just quadratics. All right, so now we just cancel out the like terms, and we have z plus 3, and z minus 1. Now there's two z minus 1s on the top, and actually there's 2 on the bottom. I was going to say you can only cancel 1 out, but then I saw that there's 2 on the top and the bottom. So then we're just left with z plus 8 over z minus 6. So if you got z plus 8 over z minus 6, good job. Again, this all just becomes 1. So you're just left with z plus 8 over z minus 6. All right, so for number 12, just be aware you have the difference of two squares here, and you also have a coefficient on this quadratic expression, so that's going to make things more difficult. But see if you can do number 12, and when you come back, we'll do it together. All right, we're back. So difference of two squares, what number multiplies to itself to get 81, and put your plus and minus. And we need 3a and a, not just a and a. And I'm going to try 5 and 4. 5 times 4 is 20. And I have to check O and I of FOIL. So O is 12A and I is 5A, which adds up to 17A. It doesn't work. So I'm going to have to switch the 4 and the 5. So O is 15A and I is 4A. Add those up, you get 19A. So that didn't work. So we have to try something else. It looks like 4 and 5 are not going to work. So we could try 1 times 20, but I doubt that's going to work. Actually, you know what? That is going to work. So it looks like it's going to be 20 and 1. So I should write that more legibly. So 3A plus 20 and A plus 1. So if you were tripped up by that, don't worry about it. A lot of students will not predict that it's going to be 20 and 1, because usually those numbers are not so far apart from each other. And as you can see, I got tricked there too. So in this expression, we just factor out the GCF, which would be 10A to the fourth power, which we learned how to do in previous classes. And in the bottom, we have another quadratic. So what two numbers multiply to negative 72 and add up to negative 1? So now we're ready to cancel out. We have A plus 1 in the bottom and A plus 1 in the top. And we have A minus 9 on the top, A minus 9 on the bottom. I'm going to get a smaller marker there. And then there's nothing else we can do pretty much. I don't see anything else. So now we just combine A plus 9 times 10A to the fourth, and it's common to put the GCF on the left side, but you can put it really on the right side if you want to do. And then we have the denominator. So if you got that answer, good job. All right, so on to number 13. Again, we're multiplying algebraic fractions. So try number 13, and when you come back, we'll do it together. All right, we're back. Difference two squares. Difference two squares again. And plus minus, what two numbers multiply to 25? Or what number multiplied by itself equals 25? What number multiplied by itself? What two numbers multiply to 45 and add up to 14? And then we just have to cancel out. So we have B plus 9 and B plus 9, and 3B. Whoops, sorry. 3B minus 5 and 3B minus 5. And it looks like that's it. So now we just combine B minus 9 times 3B plus 5, multiplying straight across as usual, over B plus 5. So you got that answer. Good job. Now again, the reason we have parentheses in the numerator is because you have two expressions multiplied together, but in the denominator, B plus 5 is alone. So we don't use parentheses because we're not multiplying it by anything. So for number 14, we have a special expression. We have x to the fourth minus 1, and we have a fourth and a second power quadratic. So remember, those are special expressions. So this is the difference of two squares, but it doesn't look like the difference of two squares. And this is a quadratic, but it doesn't look like a quadratic. So you can try that on your own, or you can just we can just do it together. But if you want to try it on your own, go ahead and do number 14, and when you come back, we'll do it together. All right, we're back. So the difference of two squares will be what number multiplied by itself equals 1. But instead of x and x, it's going to be x squared and x squared because it's x to the fourth power. Again, that's the difference of two squares. It doesn't look like it, but it's the difference of two squares. Factor out the GCF here and here. And then what two numbers multiply to 1 and add up to 2. But instead of x and x, you need x squared and x squared because it's a fourth and a second power. So it's getting a little sloppy here. I'm going out of the lines. I'm going to redo that. All right. So now we just have to reduce. So again, all the colored parts are the parts that are canceling out. But we have one more thing that we can cancel out, and that is these x's. So now we can actually factor the x squared minus 1, but we don't really need to. It's not going to really be helpful. Sometimes it might be, but in this case it wouldn't. So we have x to the third over x. So 3 minus 1 is 2, so that's going to be x squared. And we'll just keep the 9. And on the bottom we have 2x squared plus 1. And there's really nothing that we can reduce at that point. So if you got that answer, good job. All right, try number 15, and when you come back, we'll do it together. All right, we're back. Let's just double check that. Everything looks right. So now we just cancel out. Canceling is the fun part. So that's all the stuff that we can get rid of. All right, multiply straight across. And that's the final answer. So if you got that answer, good job. All right, try number 16, and when you come back, we'll do it together. All right, we're back. So there's really nothing that we can do on the first fraction. But we got a bunch of quadratics on the second fraction. You know what, I just realized we can't factor the denominator unless we factor out the GCF first. So there's a c that we can factor out. And then we can factor the resulting expression at that point. But we have to factor out that GCF first. So now we can factor that quadratic. What two numbers multiply to negative 40 and add up to negative 3? And now we're ready to cancel. Let me rewrite that fraction now. So we're going to cancel. And it looks like we have 2 c plus 5s in the top and 2 c plus 5s in the bottom. And we also have c squared and c. So those can, there's a c that can cancel out. So we're left with c over c minus 8. So as you can see, that simplifies quite a bit. Again, you have c to the second power over c, so that's just 2 minus 1 is 1. And the c ends up in the numerator because there's more c's in the top than on the bottom. So if you got that answer, good job. Try number 17, and when you come back, we'll do it together. All right, we're back. We have a lot of quadratics here. So let's just double check that factorization. Everything looks good. So now we just cancel out. And you can see in this case we have a factor that's common on the same fraction. So you can cancel those out even though they're on the same fraction. So it's just like the last class. So the factors don't necessarily have to be on different fractions. So we have a lot to cancel out. And you can see we're just left with z plus 2 over z minus 13. So if you got that answer, good job. All right, try number 18. You're going to have to factor out the GCF on a lot of these problems. You're going to do that first. So factor out the GCF, and then on the upper left you're going to have a difference 2 squares problem. And you just cancel out the common factors. And when you come back, we'll do it together. All right, we're back. All right, now we have the difference 2 squares, so we have to keep going. We have to keep factoring. And now we just cancel out. And of course we can cancel out the some of the t's and the 8 and the 4 and 6 and so on and so forth. So I'm just going to multiply straight across to make things a little easier. So t times 8t is 8t squared, and 6t squared times 4t squared is 24t to the 4th. Again, you can cancel out in your head, but I'm just going to multiply straight across in the numerator, straight across in the denominator, just to make it easier. So at this point, we can now reduce. It just becomes a pre-algebra problem. And if we reduce 8 over 24, that becomes 1 over 3. And whoops, that should be 8 to the t to the 4th power. I don't know why I wrote second power. And we just subtract the powers because we're dividing. 4 minus 2 is 2, and the t's are going to end up in the bottom because there's more t's in the bottom than the top. And on the top, there's really nothing there. But remember, 1 is always a factor. So we would just put 1 in the numerator. So if you got that answer, good job. Now, this problem looks like it's going to be about the same, but just keep in mind you're going to have to factor out a negative here probably. So go ahead and try 19, and when you're done, we'll do it together. All right, we're back. I'm going to try plus 5 and plus 6. O is 12 and I is 5, so 12 plus 5 is 17, so it looks like that worked. And what two numbers multiply to 20 and add up to negative 12? That would be 2 times 10. Negative 10 times negative 2. And difference of two squares, what number times itself equals 4, and put a plus and minus. So now we're ready to cancel out. And I think that's it. Now we just multiply straight across. So if you got that answer, good job. And again, it's just traditional to put the monomial term on the left side of that denominator expression. All right, so try number 20, and when you come back, we'll do it together. All right, we're back. Difference of two squares. What number times itself equals 25? What number times itself equals 64? Same thing in the bottom. What number times itself equals 36? Put your plus and minus. And let's see here. I'm going to try 4 and 4. Really have no idea what it's going to be. O would be 20 and I would be negative 4. So 20b minus 4b is 16b. So that didn't work. So let's see here. I'm going to try, we tried 4 times 4, now let's try 8 times 2. So the outside would be 10b, the inside would be negative 8b. 10b minus 8b is 2b, so it looks like that's correct. So let's just double check everything. Everything looks right. Now we just have to cancel out. Multiply straight across. And there you go. So if you got that answer, good job. All right, so now we're going to division. Division is exactly the same as multiplication, no difference whatsoever, except you first you change the sign to multiplication, and then you just flip the divisor. So change the sign to multiplication, flip the divisor, and it becomes the exact same problem that we were doing before. So we'll do this first one together. So we're going to change to multiplication, and again, you can use parentheses or you can use a dot. It doesn't really matter which one you want to use. So I'm not doing anything except just changing the sign and flipping the divisor. Alright, so now that we've done that, we can go ahead and start to factor. Difference two squares. And cancel out. Whoop, we can't cancel that one out. We can cancel this one out. And then we just multiply straight across. So again, this is just considered to be 1 times x plus 3. So if you got that answer, good job. So why don't you try number 22? Again, it's the same problem that we've been doing. The only difference is, on the first step, you have to change the sign, or change the operation to multiplication, and then flip the divisor. So go ahead and try 22, and when you come back, we'll do it together. All right, we're back. All right, we're going to factor out the common factor in the first expression. Same thing in the denominator. All right, we're going to just cancel out. And we can cancel some z's here too. So z to the second over z, that would just be z in the top. So we can write 11z. And we have a 2z plus 1 on the top also. And a z plus 1 on the bottom. So if you got that answer, good job. All right, on to 23. Try number 23, and when you're done, we'll do it together. All right, we're back. Whoops. Before I do that, I gotta do the first step. So we flip the divisor and change to multiplication. And now we're going to factor. And cancel out. And as usual, whatever's left over is the answer. But notice that I didn't put the 7a minus 6 in parentheses because there's nothing to multiply it by in the denominator. Everything else just disappeared. All right, so if you got that answer, good job. Try number 24, and when you're done, we'll do it together. All right, we're back. Whoops, I keep forgetting to show the first step. All right, and factor. I gotta write that bigger. Let's see here. What two numbers multiply to 30 and add up to negative 17? Looks like that's going to be minus 2 and minus 15. And what two numbers multiply to negative 48 and add up to negative 8? I think that's going to be negative 12 and positive 4. That's not one of your multiplication facts, so you might have had to get your calculator out for that one. All right, and it's time to cancel out. That's the fun part. A lot to cancel out on this one. So we're left with b minus 15 over b minus 12. So if you got that answer, good job. Now remember, there's a lot of potential to make mistakes when it comes to algebra. So if you're making mistakes, that's okay. Just figure out what you did wrong. All right, so for 25, something new is going to happen. Well, it's not really new. We learned it in the last class. Remember the negative 1 rule. You're going to have to use the negative 1 rule in this expression right here. Because when you factor here, you're going to get a 2z minus 3. But this is not a 2z minus 3. That's a 3 minus 2z. So just be aware that you're going to have to factor out a negative 1 here, and hopefully you remember how to do that. So try number 25, and when you come back, we'll do it together. And if you get stuck there, that's okay. We'll just I'll show you how to do it when you come back. So try number 25. Pause the video. All right, we're back. All right, and then we're going to factor, but I know that I'm going to use the negative 1 rule here, so I'm just going to go ahead and factor out a negative 1. the difference of two squares. Plus and minus. And on the bottom, it's complicated. The quadratic is complicated because we have a coefficient on the squared term. So we're definitely going to have to check with FOIL. So I'm going to try 2z and 5z. I have no idea if this is going to work, but we'll try it. And then for 6, we'll try -3 and +2. Again, no idea if this is going to work, but we just have to try. O of FOIL is going to be 4z. I of FOIL is going to be -15z. 4z minus 15z is -11z. Bingo, we got the right number. We just have to change the signs. So the negative is going to become a positive, and the positive is going to become a negative. And I really should write, let's see, 5z minus 2. I should write more legibly. All right, so let's just double check everything. Everything looks right. So now we just cancel out. So again, -3 plus 2z is the same thing as 2z minus 3. I know it doesn't seem right, but the terms are just rearranged. They have the same sign, therefore those two binomials are they're common. They're the same thing. And 2z plus 3 and 2z plus 3, and this negative is going to change the sign. We can put it in the numerator or the denominator. It's common just to keep it right in front of the fraction line. So that is the final answer. And I wrote jumbo numbers for the final answer. All right. Try number 26, and when you come back, we'll do it together. All right, we're back. And we're ready to factor. What two numbers multiply to -40 and add up to -18? That's not one of our multiplication facts, but I think it's going to be -20 and +2. All right, so now we're ready to cancel out. And it looks like that's it. So we just multiply straight across. Whoops, I don't need my parentheses because there's only one term in the top. But there's two terms on the bottom, so I need parentheses because they're multiplied together. You use parentheses for multiplication. So if you got that answer, good job. If you didn't, that's okay. Just go back and figure out what you did wrong. All right, on to number 27. Try number 27, and remember, there's a coefficient on this quadratic, so it's going to complicate things. And when you come back, we'll do it together. All right, we're back. Alright, so now we're ready to factor. Just go ahead and put all my parentheses. I'm doing all the easy parts first. And we'll do the hard part. So I'm going to try 2 and 3. And that doesn't work. O is 14z and I is 3z, so that would add up to 17z. So I'm going to try switching those numbers. I'm going to try putting the 3 here and the 2 here. And then the O is 21z and the I is 2z. Add those up, you get 23z, and it looks like that's correct. So now we just have to cancel out common factors. And what else do we have here? Z minus 9. And it looks like that's it. Multiply straight across. And there you go. So if you got that answer, good job. All right, so try number 28, and when you come back, we'll do it together. All right, we're back. There's nothing to factor on the first fraction. And only one thing to factor on the second fraction. Now we can cancel out. And we're left with nothing on the top, so we just write 1 on the top and a squared on the bottom. So if you got that answer, good job. All right. Number 29 looks like it's going to be pretty challenging, but I'm sure you can do it. You're going to have to factor out a greatest common factor on every single term. So go ahead and try 29, and when you come back, we'll do it together. All right, we're back. So now we're going to factor the greatest common factors. (42 divided by 3 is 14. And 99 divided by 3 is 33. And we're going to factor out 4. and 2. $160 divided by 2 is 80. So let's just double check everything. Everything looks correct. Alright, so now we have to continue to factor, because we still have the difference to squares, we have quadratics all over the place. So this is kind of a long one. So the 2 tells us that the two numbers that multiply to 80 have to be pretty close together. So it's got to be 8 times 10. All right, time to cancel out. And we can reduce these numbers here. But it'd probably be easier just to go ahead and multiply straight across. So 10 times 4 is 40. And 2 times 3 is 6. And again, just multiplying straight across in the denominator. All right. So there's one last thing that we can do. We can reduce 40 over 6. So I don't have much more room, so I'm just going to divide both 40 and 6 by 2 to get 20 over 3. I'll just erase that and write 20 over 3. So that was a good one. So if you got that answer, good job. Now for number 30, I want to warn you that you're going to have to use the -1 rule. You're going to have to factor out a -1 there. So go ahead and try number 30, and when you come back, we'll do it together. All right, we're back. And I'm going to factor out a -1. Actually, wait a second, I'm sorry. Before I do anything, I should just show the original expression. And factor out -1. And now we can cancel out. And believe it or not, 3z minus 8 is the same thing as -8 plus 3z. So then we're just left with -2 over -1. Negative 2 over negative 1 would just be positive 2. So that one simplifies all the way to positive 2. So if you got that answer, good job. All right, on to number 31. Now we have more than one variable. So let's try this one together, just in case you forget how to deal with multiple variable problems. All right, so we flip the divisor, change to multiplication. Now, in this numerator, we have to factor out the greatest common factor. And we have a quadratic, x and x. What two numbers multiply to 2 and add up to negative 3? That would just be negative 2y and positive y. Whoops. They'd be both negative. Factor the difference of 2 squares. Yeah, we learned how to do this in the previous class. What two numbers, or what number multiplies by itself to get 100? That's 10. So you just put plus or minus, and there you go for difference of 2 squares. So now we just have to cancel out. Multiply across. And there you go. So now you try number 32, and when you come back, we'll do it together. All right, we're back. So now we're ready to factor. We have the difference of 2 squares. We have a quadratic, but we have a coefficient on the first term, so you got to be careful. It's 2c times c, not just c times c. So what two numbers multiply to negative 1? There's only one option, positive 1 times negative 1. And factor the difference of 2 squares. And cancel out. actually we can't cancel that one out. And then multiply straight across. And again, it's customary to put the monomial on the left, although technically you don't have to. So we got that answer. Good job. So let's just double check everything. Everything looks right. On to 33. Now with 33, you need to be aware that you're going to have to use the -1 rule before you factor that difference two squares. Before you factor the difference two squares, pull that -1 out. So try 33, and if you get stuck, well, we can do it together. But go ahead and try that, and when you're done, we'll see what we can do. All right, we're back. So now we can factor. That's a big number. 25 times 10, we can separate this to 5 times 10. And if we put a 5 and a 10 together, we get 50 times 5. So 50 times 5 is 250, and if one of those is negative, that's going to work. Or excuse me, yes, yeah. So positive 50 and -5. So that was a weird one. And now we're going to have to factor out a -1. We have to use the -1 rule. And let's see here. So now that we use the -1 rule, you shouldn't have to rewrite the entire thing just to show this one change in order, but I'm going to go ahead and do that because I don't want to confuse you. But it's hard to really factor this expression, the difference two squares, unless we put it in the standard form. So I'm going to go ahead and switch those around. So instead of writing -25 plus a squared, I'm going to write a squared minus 25. That'll be a lot more familiar. So now we have a couple more lines here. Again, you don't really have to show that step, but I just want to write it so you can follow what I'm doing. All right, so a minus 5, and looks like that's pretty much it. There's not much that we could do on this one. Alright, so multiply straight across, negative 4a squared times a plus 5. Actually, we've got an a squared and an a, so 2 minus 1 is 2, so we're left, or excuse me, 2 minus 1 is 1. So we have a negative 4a, not negative 4a squared. So let's just double check that. Everything looks right. So if you got that answer, good job. So you're going to have to use the negative 1 rule on 34. So go ahead and try 34. And when you're done, we'll do it together. All right, we're back. So we're going to factor out a negative 1. You know what? Yeah. I'll just leave that. All right, so now this we can rearrange. And again, you don't have to show every single one of these steps. So we're going to rearrange that so it's 4a squared minus 1, and now it's a lot more familiar. And let's see here. (4a squared minus 1 is the difference of two squares. I'm going to write that denominator a little bigger. And we can factor the quadratic. Whoops. I just realized I should have factored out the greatest common factor. We have 2. There we go. And looks like that's it. So now we just have to cancel out. And we have a 2 in the bottom and a 4 in the top. So 4 divided by 2 is 2. So you're left with 2a to the 6th. I got to put my negative out there. And 3 factors in the bottom. So there you go. If you got that answer, good job. All right, on to number 35. Looks like we have 3 more problems. Actually, we have 4 more problems. And don't miss this negative here. There's supposed to be a negative there. Move that number up. So you're going to have to factor out a negative here. That's important to understand. And also notice we have a fourth power and a second power on that quadratic. So that's going to be that special type of quadratic, so keep that in mind. So try number 35, and when you come back, we'll do it together. All right, we're back. So we need b squares. So it's not just b minus 9 times b minus 1, it's b squared minus 9 and b squared minus 1. Because it's b to the fourth and b to the second. Factor out a negative 2b to the fifth. And at this point, we have to actually keep going. We have to continue to factor, because notice we actually have the difference of two squares here. So I'm going to continue to factor that. And also, I just noticed we have the difference of two squares here also. But we're not going to need to factor that, because that's not really going to do much for us. So that's a relief, because we'd have 4 factors in the denominator of that fraction if we had to do that. Alright, so now we can start to cancel out. Because a b plus 3 popped out and a b minus 3 popped out. And we can also reduce these b's, 5 minus 4, because we're dividing power expressions, so we subtract the powers. And you're left with b on the top, and of course a negative times a negative is a positive. So we're just left with 2b all over b squared minus 1. And I think that's it. So again, we can factor this b squared minus 1, because that's the difference of two squares, but we don't really need to. We only factor it for the purpose of simplifying the expression, but we don't really need to simplify the expression there. Alright, so on to number 36. You're going to have to factor out a negative here and here, it looks like. And so try 36, and when you're done, we'll do it together. Alright, we're back. Whoops, I just realized that went out of the page there. Sorry about that. All right, and now we're ready to factor. And looks like we can factor in negative 3b to the fourth. That would just be 25. And we can factor a negative 1. And we're going to continue to factor. I'm going to try positive 1 and negative 5. I got to write that more legibly. And looks like that's not going to work. O of FOIL is negative 10b, I is 1b, negative 10b plus 1b is negative 9b, so that's not even close. So I'm going to try switching the numbers. I'm going to try positive 1 here and negative 1 here. O is negative 2b, I is 5b, negative 2b plus 5b is 3b. So that's bingo, we got the right number. We just need to switch the signs. Because we got a positive 3b, we need a negative 3b. So I'm going to switch that to negative 5 and that to positive 1. And there we go. And that's a difference of 2 squares, so we can go ahead and factor that. I don't need to move this over. What number multiplied by itself equals 4? What number multiplied by itself equals 25? And plus and minus. And what two numbers multiply to 36 and add up to negative 13? That would be negative 4 and negative 9. All right, so we're completely factored at this point. Now we just have to cancel out. Let me use that other color. And we also have b's. B to the fourth over b to the second would just be b to the second. So we're left with negative 3b to the second, 2b plus 5 in the numerator. And we have two negatives, a negative here and a negative here. So those negatives are just going to cancel out. So we can just get rid of the negatives completely. And on the bottom we have b plus 1 times b minus 4. So if you got that answer, good job. All right, don't worry, we only have 2 more. That's it. Now again, if you're wondering why we're doing all this stuff, well, it's to show you the concepts, but also to review how to factor algebraic expressions. So for 37, let's do that one together. It looks really difficult, but it's not that bad. We're just going to factor everything as usual. And then we're just going to cancel out. The only difference is we have a bunch of fractions we're multiplying. So we're going to first start by factoring the GCF there. And I'm going to rewrite this because this is kind of a trick here. That's negative 9 plus x, but we need to write it as x squared minus 9. Because then it's just more familiar. Here we have a negative on the first coefficient, so we don't like that, so we're going to use the -1 rule and change all the signs. And we're going to factor the difference of two squares here. And we can't do anything with x plus 4, but we can factor out a greatest common factor. Whoops, that should be third power. Alright, so now we just have to continue to factor. We have the difference of two squares. Then we have a quadratic. And now comes the easy part because we're going to cancel out common factors. Alright, so let's see here. What do we recognize? I have an x plus 3. We have x plus 1. We have a x plus 4. Again, if it's in the top and the bottom, you can cancel them out. And I think that's about it. Well, actually, no, there's one more thing. We have an x to the third and an x to the sixth. So those can reduce. So the greens, x to the sixth over x to the third, that would just be x to the third. And before I forget, I'm going to go ahead and write that negative in front of the fraction sign, fraction line. And we have x minus 3 times x minus 8 times x minus 1 times 6x minus 5. All right, so that was a big one. All right, so time for you to try one of those, and this will be the last problem for this class, and then all you have to do is your homework. Just be aware before you try this problem that this expression here is one of those special quadratics where you have fourth power and second power. So when you factor, you're going to have x squared and x squared as opposed to x and x. Also be aware that you're going to have to switch this around and make it x squared minus 49. So it'll be recognizable. And not only that, but you're going to have to use the -1 rule here, it looks like. Actually, what I mean is you're going to factor out a negative here. So go ahead and try 38. And when you come back, we'll do it together. All right, we're back. So again, this is going to be x squared and x squared. What two numbers multiply to negative 16 and add up to negative 15? That's kind of a tricky one. I think it's going to be negative 16 and positive 1. So if you got confused on that, don't worry. A lot of students would get confused on that. I had to look at that for a while myself because it's not a normal quadratic. All right, and then we're going to factor out the common factor on the denominator, which should be 9x. And factor out the quadratic. Factor out a negative 5. And we're going to switch these terms around now so they look more familiar. So now we see it's a difference of 2 squares. It was hard to see when it was negative 49 plus x squared, but now we can see it's a difference of 2 squares. So now we're going to do one more step and factor a little bit more. So do you see the x squared minus 16 here? We can continue to factor that because that's a difference of 2 squares. Let's go ahead and do that. What number multiplied by itself equals 16? Obviously it's 4. I'm going to rewrite that a little bit. X plus 7. So now at this point we can cancel out. So x minus 4 and x minus 4. Those are the same term. They don't look the same, but they're just rearranged. And we have x plus 4 and x plus 4. Now this is something interesting because notice how we have an x plus 4 here too, but we cannot cancel that out. You can only cancel one x plus 4 because there's only one x plus 4 in the denominator. So hopefully you didn't get confused by that. What else do we have here? We have an x plus 7, it looks like. And we have an x in the denominator. And we have an x squared. So now let's try to put this stuff together. So the purple, x squared over x will be just x. And we're going to, and also 3 over 9. Use the fundamental principle of fractions. Divide both 3 and 9 by the same number, and you get 1 over 9. So the 3 is going to disappear, and then you're just going to, the 3 up here is going to disappear, and you're going to end up with 3 in the bottom. So we have x, whoops, should write that in the same order. Left to right. I think that looks right. Just double checking. And We have 3 in the bottom, but we also have a negative 5 here. So we're going to have to multiply 3 by negative 5. And again, you could just multiply straight across. You could do 9 times negative 5 and get negative 45 in the denominator. And keep your 3 and then reduce it later on. So then you would have 3 over negative 45, and then you would just reduce that. But I'm just skipping a step. So we have negative 15 x plus 8 and x minus 9. And it's traditional, again, to put the negative, take that negative and put it either in the numerator or in front of the fraction. Just make sure you write it nice and big and don't run it into the fraction line, because then it will disappear completely. So that was a tough one. If you got that answer, good job. So that was the class today. That was a long class. This is all the work that we did today. If you'd like to take screenshots of these pages to help you with your homework or to study for tests, go ahead and do that now. But don't go before you get your homework. Get a screenshot of these first 2 pages and the last page. And be sure to do that homework completely, correctly, neatly, and put it in order in your binder. And remember, writing the answer doesn't really tell you much. You need to show the factoring and showing all the canceling out, and that's going to prove that you did the work. So get that homework done, and I'll look forward to seeing you in the next class.